So we're going to be looking at addition and subtraction of complex numbers. Okay, so addition and subtraction of complex numbers. So this is what we're basically looking at today. So we're going to start with addition. So with addition, we have a situation whereby we have, let's say, z is equals to a plus ib, right? Then we also have the situation where we have w is equals to u plus ib. Okay, so what we simply mean when we add the two complex numbers, this is what this simply means. So we can do this in this way. So we're going to have a plus ib plus I. Okay, so when we have a situation like this, we get the real parts, we add them together as well as the imaginary parts. So we're just getting like terms in this case. So we're going to get a and u, add them together. So we're going to have a plus u. Then we're going to have, we're also going to get ib plus iv. Okay. Then to just simplify this further, what we're going to do, obviously we have our real part here, we add the real parts together, then we're going to factor out the I, so that we just remain with the real numbers inside here. So which is B and B, so we're going to have plus I, B plus B. So mostly this is what we're going to look at when it comes to addition of complex numbers. So to just help us understand what we are talking about here clearly, we are going to just have an example with actual numbers that we can use to just help us understand the addition process. So this is just maybe something that we use to just help us define what goes on exactly, maybe the process of adding complex numbers together. Okay, so we're going to have an example here. So we are being asked to find the sum of obviously z plus w. So our z is going to be 4 plus 5i, right? Then our w is going to be 3 minus 2i. So we're being asked to find the sum of these two. So we're going to have z plus w is equals to 4 plus 5i plus our w, which is 3 minus 2i. If you remember what we said earlier, we're going to get the like terms. So we're going to get the real parts together and add them together. We're going to have 4 plus 3, okay? Then we're going to have plus here again. Then we're going to have, we're going to get the imaginary parts as well, add them together. We're going to have 5i, okay, plus negative 2i, okay? Yeah, so that's what we're going to do there. Then what we're going to do is when we add the real part, we're going to have what? We're going to have 7 here, okay? Then on the other side, we're going to multiply the negative and the positive, so which is just going to give us 5i minus 2i. So the next thing that we need to do now to simplify this further so that we can find our final answer is obviously factor out the I. So when we factor out the I, we're going to have plus I, then we have 5 minus 2 in there. Then our final answer should be 7 plus, when we subtract 5 minus 3 minus 2, we're going to have 3. And 3, the 3 times this I, we're going to have 3i. Okay, so that's going to be our answer. So this is how we add complex numbers together. Yeah. So after this now, we're going to look at our second example. So with complex numbers, adding and subtracting complex numbers is not something that's very difficult. So it's just something that's straightforward. And yeah, so we're not really going to spend much time on it, on the addition and subtraction. But at least we want to see if we can get to multiplication as well as just look at the conjugate and the modulus of complex numbers. The next time we meet, we're going to have to look at the division of complex numbers and maybe even start subs. So our second example says that find x and y, right? So we're being taught to find x and y, okay, such that we have two complex numbers, which are 3x minus iy, okay, plus 2 plus 13i, okay, which is equal to another complex number, which is negative 7 plus 3i. All right, so in this case, we're going to have to look at what we did last week to do with equating complex numbers when are two complex numbers equal. So we know we're going to just have to use that concept here to just help us solve this. So when solving this, what we're going to do first is we're going to first start with the left-hand side, okay? So we're going to first add the real parts and the imaginary parts on the left-hand side, which is this part. So this is the right-hand side, and this is the left-hand side. So we're going to first start by adding the real parts and the imaginary parts together. So combining the like terms, we're going to have, combining the like terms in this case now, we are going to have 3x plus 2, okay? So 3x, getting the other real number, real part there, which is 2, plus 2, okay? Then we're going to have plus, we're going to get iy and 13, negative iy and 13, so we're going to have 13i minus iy. So the arrangement really doesn't matter. We can still start with the y and the negative y and have plus 13 there, so it's still one and the same thing, equals to negative 7 plus 3i. After this, what we do next is we now equate. Okay, so after we've done this now, we first of all, before we actually equate, let's just simplify this further. We can say 3x plus 2. Okay, we factor out the I, we're going to have plus I here, and we're going to have 13 minus y equals to negative 7 plus 3i. So now that we have this, okay, now we can now use the equating, the equating concept of complex numbers. So when we equate two complex numbers, we need to equate, or two complex numbers rather can be said to be equal when the real parts and the imaginary parts are what? Are also equal and stuff. So in this case, this, what we have here is, this is one complex number. So this is the real part of this complex number. This is the real part. Okay, and this is the imaginary part of this complex number. Okay, so this is, we're going to take this as one complex number for now. So this is one complex number and this is another complex number. So now that being said, we can simplify this further by equating these two complex numbers, because we have an equal sign here. So which means that this complex number on the left-hand side is equal to the complex number on the what? On the right-hand side. So we're going to have to equate the real parts of this complex number to the real part of this complex number, and also the imaginary part of this complex number to the imaginary part of this complex number. So by doing so, all we're going to say is, we're going to say 3x plus 2, which is the real part of this complex number, is equal to what? The real part of this other complex number, which is negative 7. And then on the imaginary part, we are not going to consider the I in this case because we're just dealing with this part here, right? So we're going to get the 13y, which is the minus y, which is an imaginary part in this case for this complex number, and get the 3 here, which is also an imaginary part of the other complex number. So we're going to have that. And now in this case, we have two equations that we can actually use to solve for x and y, because the whole point of doing this is to find the values of x and the values of y. So now we have two equations which we can use to actually find the values of x and y. So someone yesterday asked about why we can't really use simultaneous equation in this case. And someone helped us to explain that, and I also added on to it to say that equations like this, so we're going to take this as one equation and this also as one equation. And we also know that this is a variable and also y is a variable. So when an equation has one variable, you know, or you have two equations and both equations have one variable. So here, this equation on top has one variable, and the equation at the bottom has one variable. So it's really impossible for us to use simultaneous equation in this case. So if we're going to have if we use simultaneous equation, both equations need to have two variables. So what we mean by that is that 3x plus 2 is going to need to have a y here, and then the one at the bottom is going to need to have an x. So which means that both the bottom equation and the upper equation have two variables, but in this case, they only have one each. So we can't really use simultaneous equations. So we just have to opt for another method, which now is what we're going to do, which I'm pretty sure most of us have done, know about, obviously. So that's 3x plus 2 here, and here we have 13 minus y. So the method that I'm talking about is simply just making x the subject of the formula. So making x and y the subject of the formula. So doing that, we're going to start with the upper equation. So we have 3x here, all right, plus 2 is equals to -7. To make x the subject of the formula, we're going to have to take 2 to the other side. So we're going to have 3x minus 7 minus 2, because when you take it to the other side, it changes to negative. And then when we negative, so we have two negative numbers here. So we're going to add, obviously, for us to find the answer on the right hand side. So we're going to have 3x is equals to -7 minus 2. Okay, is going to give us -9. Then making x the subject of the formula, we divide by 3, cancel that. And 3 into -9 is simply just -3. So our x value there is -3. Then we do the same for the bottom equation. So we need to make y the subject of the formula. So we're going to have 13 minus y is equals to 3. Taking 13 to the other side, we're going to remain with -y is equals to 3, okay, minus 13. Okay, that being said, we're going to have -y. Okay, when we subtract 3 minus 13, we're going to have -10, because obviously the larger number has the negative there. So our answer there, or rather the difference, is going to be -10. So we divide by -1, divide by -1. You can still say divide by negative, divide by negative. It's one and the same thing. So negatives cancel out. 1 into y goes, it's just y. Then negative there cancels out, negative there cancels out. 1 into 10, it's just 10. So our answer there is 10. So our x is equals to -3, and now our y is equals to 10. So yeah, I think that's pretty much it for this question, or for this example. So we're done with the addition part of complex numbers. Do we have any questions concerning what we've done so far?
Hello.
Yes.
Hello, sir.
Yes, you have a question?
Yes, I have a question. Yeah, I do confuse like the issue of addition and subtraction of complex numbers. Like, how do you know that this is addition here, which is being applied, or this is subtraction, which is being applied? How do you know?
Okay, so you'll be able to tell by the type of complex number. They'll tell you what to do. So like in the first example here, the question said find the sum of z plus w. So they'll give you maybe the question, so find the sum of, let's say, z plus w, okay? So they'll say, yeah, okay, let me put it in this way. So they'll say maybe z is equals to what? A plus ib, right? Then they'll also give you w as well. So w is equals to u plus iv. So in a situation like this, the question will further on say, or tell you that, okay, you have two complex numbers, this and that. So find z times plus w. It's going to show you that, so you know that this is addition. For subtraction as well, they might give you the same thing. So all they'll do is say find z minus w. Multiplication as well, they'll tell you, maybe for multiplication, they'll just say they'll give you two complex numbers. They'll ask you to multiply the two. They'll say Z times W. And obviously for division, we're going to have that. So that's how you know. The question will actually specify. Yes, I see a hand. Are you okay on that one?
Yes, sir, I'm okay.
I saw a hand just now. You can ask your question?
Yes, I'm having a question.
All right.
Is it possible that you may be asked to prove on the equations?
To prove on the equation, what type? So you mean just in complex, just in the complex number topic, just in general, like can you be asked to prove something using complex numbers?
Yes.
Yeah, the situations where you might be asked to prove something. So I'll show you an example later on when we come to maybe when we look at the modulus and the conjugate of complex numbers. So there might be situations where you might be asked to just prove something, but it's not difficult.
Okay.
All right. All right. So for now we can move on to the next thing, which is subtraction. So for subtraction, similar case as well. It's not that different from addition. So you have a situation where you have Z again, which is equals to A plus IB, right? Then you have W, which is equals to U plus IV. Okay. So if you're asked to say find the difference of Z and W, so which is Z minus W, you're going to have a situation where you have A plus IB, okay, minus U plus IV. So yesterday, a friend of ours, one of our friends, I think that's her name must be Sintra. Yeah, she gave us maybe another method that we can use to actually find or subtract complex numbers and stuff. So I did some further research and stuff. Then I found more methods and stuff that we can actually use. And I found that maybe this method that I'm going to share right now is actually easy, which is what she actually suggested yesterday as well. It's easier and straightforward, and it's less confusing rather than what we did yesterday. So just for the sake of this, us having a perfect understanding, so I'm just going to show you this one instead. So we have two complex numbers there. Okay, so that's A plus IB, U plus IV. Okay, so we have to find the difference of that. So to just make things easier for us is that when we're simplifying this, we get the real parts, we add them together, okay? Or maybe before we do anything, what we can do is we distribute the negative with everything there, with everything inside in here. So what we're going to have is we're going to have A plus IB, okay? Negative distributed with everything in there, you're going to have negative U, then you're going to have negative IV, okay? So what we're going to do now is get the like terms. So when we get the like terms, we're going to have A minus U, then plus IB minus IV, okay? So we're going to have a situation like this. Okay, then we factor out the I. When we factor out the I, we're going to have A minus U. Then we factor out the I. So that it's going to be plus I, B, B minus B. So I find this much easier. So to just understand what I've just shown you guys right now, we're going to have an actual example where we just use numbers. We use actual complex numbers and stuff to just help us understand. Okay. All right. So for this example, we have a situation where we have we're being taught to find Z minus W. Okay. So our Z in this case, or Z, is 4 plus 5I. Then we have our W, which is 3 minus 2I. All right. So we're going to have W equals to 3 minus 2I. Okay. So in this situation, all we are doing now is we're going to say Z times W is equals to 4 plus 5I, then minus that, which is 3 minus 2I. Now that we have this situation here, so we can, instead of doing it the way we're doing it yesterday, so we first start by distributing the negative with everything inside. So we're going to have 4 plus 5i. The negative times 3, we're going to have negative 3. Then we're also going to have a positive 2i here. Sorry, yeah, a positive 2i. We get the like terms. Okay, so once we get the like terms, what's going to happen is that we're going to have 4 minus 3. Okay, then we're going to have plus 5i. Okay, we're going to have plus 5i. Then we're going to have the plus 2i here. Okay, so we can just do that. All right. So now in this case, to just simplify this further, we're going to have 4 minus 3. We're going to have 1 here. Then we're going to have plus. We factor out the I. We're going to have an I here. Then we're going to remain with 5 plus 2. And obviously we know that 5 plus 2 is just simply 7. Just simply 7. So when we multiply the I with everything, our final answer is going to be 1 plus 7i. Okay, so this is how we can do it, and I think this is a much simpler way that can help us understand how the subtraction of complex numbers works and stuff. So do we have any questions on subtraction?
I have a question.
Yes.
Though it's not exactly on subtraction, about distributing the sign.
Okay.
Can we do the same with addition?
With addition, it's just straightforward, really. You don't really need to distribute anything, but it's the same thing, yeah. You can get the like terms together, but if you remember how I did it is I just gathered them, I just got them separately. Like I just got, for addition, we had to think a similar situation. So let's just assume this is addition. Okay, I think we remember what we're eating here.
Before you wrap up, I have a question or not?
Okay, I'll just let me just answer her. Then I have the solutions. Don't worry. So I'll show you everything again. So we have this, right? So let's assume this is addition. What's going to happen? It's easier. So all you're doing is just it's one and the same thing. Because even if you distribute the positive, you're just going to get the same thing as this. Okay. So there's no difference really with addition, but with subtraction, that's where you really need to be careful. Because with subtraction, that's where things actually start to change. So even if you distribute this, get the like terms, you're still going to have a positive 3. And when you multiply this positive with the negative, you're still going to get negative 2i. So there's no difference really. So all we have to do is just get the 4, add it with the 3 there, okay? Then on the other side, if we factor out the i's in advance, we're going to have a 5, okay, plus negative 2 here. We need to be careful with the negatives when adding, if a number has a negative on the inside. So we need to remember that we're multiplying the negative there with the positive because we're adding the complex numbers. We're adding the real parts together and we're adding the imaginary parts together. So we have 7 there. And then when we do that, we're going to have 5 minus 2, obviously, which is just 3. So our final answer is going to be 3i. Okay, so that's what happens. I hope you're okay with that one.
Yes, I'm good. Thanks.
Okay, so someone had a question with the previous one. Go ahead and ask.
I wanted to ask on the part where you factor out the I.
Okay.
Yes. Will I lose marks for skipping that part? Let's say since, what was that? That was 3i minus 2i. I just got direct and subtract the 2 without actually factoring out the I.
So you just do what?
I got direct, you know the way there's 3i minus 2i.
Okay, so let's assume
So we have 3i.
4 minus 3 here, right? Then
Yes.
you go directly and say plus I. You have 5 minus 2 there. Is that what you're saying?
Yes. So in this part, yes, where you're factoring out the I.
Okay.
That same part. Yes, let's say I skip that and just go direct without factoring out the I use the like terms thing and say 5i minus 2 and subtract them in advance without actually factoring out the I. Will I lose marks for that?
No, you won't really, because it's one and the same thing. Because if you're still ending up with the final answer, because so what you're saying is simply this. So you have a situation where we distribute the negative, right? So we're
Yes.
going to have 4 5i, then negative 3, positive 2i, right? Then
Yes.
what we're going to have is now 4 minus 3, okay? So 4 minus 3 plus 5i plus 2i. Okay, then you have 1 there. Then you have, then you're going to have what? You're going to have 7 there, plus 7i. No, this is actually even much more straightforward, so you won't lose any marks.
No. Okay, thank you.
You're welcome. Any other question on this? Yes, Abel?
This W, is this 3 or 5?
Sorry?
Here, where W, what's the value of W? Is it 3 or 5? My network was breaking. Is it 3 minus 2i or 5 minus 2i?
This is 3 minus 2i.
Oh, I wrote 5. All right, thank you.
All right.
Okay. It's about the previous answer that you found. 1 plus 7i. Isn't it supposed to be 1 plus 3i? Since we are subtracting
You mean the previous thing that I had here?
this same one, 1 plus 7i. Isn't it supposed to be 1 plus 3i?
No, it's 1 plus 7i, because what happened there is we didn't really distribute, right? So when we distribute the thing, what we're going to have here is we're subtracting on the inside. So what show you this to make you understand. So I didn't really show it in full because we're just trying to make her understand a certain point. So what we're doing on the inside here, right? So we have this whole thing. So in this case, what we're doing here is we're subtracting. Okay, we are subtracting the thing. This is subtraction. So we have this too. So when we subtract, we're going to subtract the real parts, and we're also going to subtract the imaginary parts for subtraction. So we're going to have 4 minus 3. We're subtracting here, yeah? Okay, 4 minus 3. And then if you still have a thing, so we're going to say plus here, all right? Then we're going to have 5 minus negative 2. I don't know if you get what I mean. You see what, because this 2 is an individual, so 5i here and 2i here. So this negative 2 is an individual thing. So when you're subtracting the imaginary parts together, this subtraction is just different from this one. So you have to put it in this way. So it's the same thing that we did when we're adding, if you remember when I showed you the adding example. So with the subtraction example as well, it's the same thing. You need to be careful about this negative sign over here. So when you consider the negative sign on the inside here, you're going to have 1 here, obviously. Then you're going to have plus I, okay, that plus that. So we're going to have 5 plus 2 on the inside, which is going to give us a 7, leading to our answer being 1 plus 7i. I hope you understand.
Yes, thank you.